Hi, welcome to Hotspot, and I'll be discussing my fire incidents microservice with you. So this is just an example of what our client-facing, our front end would look like. So a customer searches the neighborhood or zip code, and we are going to serve up the first 3 months, most recent 3 months of data of crime rate, fire rate, and health inspection of that area. And we'll also give a prediction of whether the housing value in that area will go up or go down in the near future, depending on these three criteria. This is our high-level architecture. What we do we split it into the online process and the offline process. And basically what happens is that in the background, we have our job that runs 24 hours. For my case, it runs once a day, and it'll grab all the updated data of fire incidents into the data warehouse. And we'll have our background worker that also then puts it into the local Postgres within my microservice so that my fire incidents data will be able to access it. So some interesting thing that happens is that we actually do some caching, but what do we cache? That was, yeah, we'll talk about that right now. So since 2003, the 4 areas of the highest fire incidents were Tenderloin, South of Market, and Russian Hill and Mission. And also the 3 lowest fire incident areas were west of Twin Peaks, Presidio, and Treasure Island. So we thought these will be like areas of high interest, and so we are actually going to pre-fetch the data and cache it for 23 hours because we know that our data does not change within the 24 hours. So we want to cache for 23 hours when it first grabs the data. When it updates the data, the background worker, it will then prefetch it to the Redis. And we actually have another on-demand caching service that will hold for 10 seconds for any custom queries that the client will do. And this allows us to then we're able to see that the latency is significantly reduced when we do both the prefetch cache and on-demand caching. So how do we know that? We did some time series monitoring with using StatsD, which sends packets of data to Graphite, and Graphite listens on to those and collects that data. And then Grafana is a better user interface to be able to visualize our data better. And finally, we're using log entries so that we can track down what happened when there are latency spikes. And we'll do a live graph demo. So this is what Grafana looks like. The top is the app latency versus time. It should be more like my microservice latency versus time. And the bottom here is how many times the client queried my microservice over time. The orange here is actually how many times the server hit the cache to grab the data, and the blue/green line here is how many times it hit the database to grab the data. And at this point in time, I actually shut off the Redis, and you can see that now all my queries are going to the database to grab the data. And then I increased the queries from 1 queries per second to 20 queries per second in this later half. So how does that affect our latency? We're able to see that when we are using the cache, we have an amazing performance. The latency hovers around 20 milliseconds on average, and there's sometimes spikes of up to 235 milliseconds. And we can go to log to see what happens there. And but when we shut down our Redis, we're able to see that suddenly there is all of our latency starts going up to above 1 second. And there are certain spikes that go up to 3 seconds. And when I increase the query count from 1 to 20 queries per second, now you see there's a massive lag where the server is not able to handle properly, and there is sometimes as slow as 19-second latency, which is unacceptable. And at this rate, we'll have to ping our message bus to let an engineer send an email to an engineer saying that there is a problem and it needs to be handled. And so our next steps are actually to set up monitoring on our gateway server, set up series of controlled load tests at our microservice level and also the entire app level. And our goal is to be able to hit 2,000 queries per second and have P95 of less than 200 milliseconds. And right now, we're currently deployed on Heroku, and we want to kind of migrate to AWS using EC2 to see maybe if there's an increase in performance or stability in terms of the query count, because you saw that the graph was a little bit jagged. And we also want to complete the prediction aspect and also set up a chaos monkey test where we shut down different things, like how you saw me shut down the Redis and saw how it changes our behavior. We want to make sure our app is robust and be able to handle when random components fail. And so we'll identify some failure modes and be able to handle those failures properly. Thank you.